we're going to look over trig ratios, and like you said, you recall this acronym SOHCAHTOA to help you remember how to go through primary trig ratios, and that's important. These are specifically primary trig ratios, and the reason they're primary is they only work with a certain type of triangle. Do you recall which one?
Right angle triangle.
Exactly. They're really only going to work when we have a right angle triangle. The inverse ratios of these. So we have inverse ratios. So for instance, SO stands for sine theta is equal to
opposite over hypotenuse.
Exactly. So this is considered cosecant, and this is the inverse of our sine. So in other words, when we go to write it, cosecant theta, do you know what our inverse stands for? What it refers to?
The reflection on the line x equals y equals x.
Yeah, you're right. It can definitely be considered like that. Another way to think of it is an inverse of the ratio or the fraction that it's equal to. So cosecant is also equal to our hypotenuse over our opposite. Okay? And another way they tend to represent it is cosecant. Oh, I forgot to get that C in there. Cosecant is equal to 1 over sine theta. Okay, that's how they usually represent it. So this will be the most common way they'll represent it. But say you wanted to actually refer cosecant to sides of a triangle, it's just the inverse of what we had before. Okay? Have you guys talked about that one at all?
No.
No? Okay, so we'll talk about all three. Cos theta, we'll do them in different colors here, is equal to the adjacent over the hypotenuse. Right? So if I was to tell you that secant was the inverse of cos, what would its ratio be equal to?
Hypotenuse over adjacent.
Exactly. Okay. And then what would probably be the most common way they'd represent secant theta then?
1 over cosine theta.
Yeah, that's exactly right. This is the most common way to represent it. And then finally the last one, tangent theta, what is that equal to?
Opposite over adjacent.
Yep. Adjacent. Which means cotangent theta would
adjacent over opposite.
And then finally, what's the most common way to represent our cotangent theta?
1 over tan theta.
Excellent. Pick up very quick. Good. Okay, so these are just some inverse functions or inverse ratios, and with some of your questions, they may give you a right angle triangle. So let's just say we were given a right angle triangle. We'll create one down here. Let's say we're given this right angle triangle, and this so happens this one. Well, actually what we'll do is we have to talk about special triangles also. So we'll talk about special triangles and also related to cosecant, secant, and cotangent. But there's are two specific triangles that we have to remember, or essentially memorize. Okay? And let's go down a bit. Now, this triangle here is an equilateral triangle, which means the angles are both going to be 45 degrees. All of our special triangles, or the two that we're going to remember, are both going to be 90 degrees. They're going to be right angle triangles. Okay? They have a special ratio. So usually it's represented as this side length being 1, this side length being 1, which would make the hypotenuse root 2. Okay? The other special triangle deals with 90 degrees, 60 degrees, and 30 degrees. Okay? And its ratio is known as 1, so this side being 1, this side being root 3, and the hypotenuse being the distance of 2. Okay, and you're going to eventually start to relate these to each other a little later on. But these are two triangles we have to remember. So we're actually just going to use our basic primary trig ratios and their inverses and get used to setting up the ratios of them. So let's say we're talking about, we'll call this the first one. If I was setting up sine of 45 degrees, okay, what would that ratio be equal to?
1 over root 2.
Yeah. And does the other angle change?
No.
No, because they're both 45 degrees. So they're going to be identical to each other, which means cos 45 will give us what?
1 over root 2.
Identical, right? Because the two side lengths are the same. And then tangent for this same triangle, tangent will give us what?
1 over So 1.
Exactly. It'll give us exactly 1. 1 over 1 is 1. The inverses of these functions, actually we'll talk about those after. Let's actually jump to the second one first. Now this one's going to have two different ratios when we do them. We're going to have sine of, let's start with the smallest one, 30 degrees. Sine 30 degrees is going to be equal to what ratio?
1 over 2.
Not sine, sorry. Cosine 30 degrees will give us what?
1 over 3.
Close. It's adjacent over the hypotenuse.
Sorry, root 3 over. So root 3.
Root 3 over what?
Over 1.
Not 1 because we're looking at the hypotenuse, right?
Over.
So you were right for the first one when you said 1 over 2 because that would be the opposite side. This would be hypotenuse. Hypotenuse doesn't change, right? So it's going to be root 3 over 2 in this case. Good. And then our tangent 30 will give us what?
1 over root 3.
Ah, good. Now, you're going to be able to figure out a pattern very quickly here. Let's see if you can get it. If I were to say sine 60 degrees, what would that ratio be equal to?
Root 3 over 2.
And what is that similar to?
To cosine 30.
Yeah, that's right. These two are going to be the same ratio, which probably means what is cos 60 going to be?
1 over 3.
The hypotenuse is still the bottom.
Yeah, 1 over.
1 over 2. Which one is that very similar or equal to?
Sine 30
That's exactly it. These two end up being opposite ratios of each other depending on what angle we're talking about. Okay, so when we're talking about different angles, they actually end up with the same ratio. Okay, and finally, tangent 60. Do you know what that one's going to be?
Root 3.
Root 3, exactly. It's technically root 3 over 1, or the inverse of what we had before, right? So we've set those all up. These triangles are very important. We're going to have to memorize them as we go through. And we could talk about the other ratios, but I think that's a good start. So these are some primary trig ratios with special triangles. We've just kind of set them up to start.